In today's video, I want to talk about the challenges when we build in or evaluating coding agents. So each of these challenges involves making decisions about how a coding agent perceives, interprets, and interacts with its environment. In developing robust coding agents, balancing the flexibility and capability of the agent with safety and performance constraints is delicate but essential tasks. So let's get started, and now we're using a concrete example to clarify each aspects. The first challenge is defining the environment. If we try to build coding agents, we must clearly define an environment that mirrors the real-world software development as accurately as possible. So this environment serves as a sandbox that agents can interact, make changes, and get feedbacks on its actions. The one example is, let's consider an agent tasks with developing a small web application. So this environment might include various libraries, frameworks like React or Flask, or a simulated production environment to test and deploy the application. So if we set up an environment that lacks of component like a mock server or database, then this agent's ability to make and test backend changes will severely limited, right? And similarly, if this environment has limited access to some specific APIs or tools, then this agent might not learn or adapt to a broader coding tasks that the real-world coding demands. The second challenge is designing observation and actions. So observations and actions define sensors and movements of the agents in this environment. So for the coding agent, this challenge is to create an appropriate set of actions like writing code, testing, and debugging. And the observation is like code syntax errors or test results to make these agents' interactions more efficient and meaningful. One example is in debugging task, an agent might need to observe syntax errors from a linter, or check for runtime errors from a console, or note the failed test cases and the error messages. So these actions available to this agent could include like writing or deleting lines of code, calling some specific functions, or modifying parameters. So if this observation space is poorly defined, then this agent might have to overlook the important clues like test failures or continue to run some buggy code, which making it harder for it to learn or improve. The third challenge is code generation, which is atomic actions, which is unlike simpler agent actions like move forward or grab objects. The code generation requires defining complex atomic actions that can produce functional, syntactically correct, and contextually relevant code. For example, let's say we have an agent that is assigned to create a Python function to calculate the area of triangles. These agents' atomic actions might include writing code line by line, or choosing variables, or identifying code structure, such as define a function called triangle area that takes two parameters, base and height, and inside this function, we return the result of 0.5 multiplied by base and height, these two parameters. So to achieve this, the coding agent must leverage the language models which are trained specifically for code like Codex or AlphaCode. So these models need extensive data set that tuning to produce lines of code that integrate smoothly into the existing code bases, which can be a highly complex process given the variety of coding style, language, and context. And the fourth challenge is file localization or exploration, like agents in reinforcement learning who explore environments. So coding agents must explore large code bases to locate relevant files or code section to modify. So these involve navigating a potential complex structure of files or modules to find the exact location where a change is required. For example, suppose the agent is assigned to update the authentication flow of an application. it needs to locate relevant authentication files among all the potential thousands of other files. So the agent might start in main file and then detect an import auth line and then navigate into the auth directory to locate a specific function like login or verify user. So it is effectively finding and editing relevant files without making unnecessary changes is essential. And this is a significant change, especially in the large unfamiliar databases. And the fifth challenge is planning and error recovery. So the coding agents need a mechanism to plan their tasks, which is breaking down the complex coding tasks into manageable steps and recover from errors, which is identifying and correcting mistakes without any intervention. The example is just imagine an agent which is attempting to implement a login feature. It plans the following steps. First, it writes a function to authenticate user credentials, and then validate user input, and then integrate the function with the main login flow. So if the agent encounters any errors, for example, invalid credential handling, it needs to detect this, which is diagnose why the login function failed, such as incorrect parameter handling or something like that, and finally attempt to fix, right? So planning requires sequencing tasks logically, while the error recovery involves understanding the root cause of the failures. So a significant hurdle given that many errors can be subtle or context dependent. The last challenge, let's talk about safety. So ensuring that coding agents operate safely is paramount, especially when they have access to live system or production-like environment. So without proper safety checks, an agent's action could cause unintended data loss, system crashes, or security vulnerabilities. For example, let's consider an agent which is granted access to a database for automated testing purposes. If the safety mechanisms aren't in place, then this agent could accidentally delete or modify sensitive data, which will cause irreversible damage. So safety precaution is very important, which could include setting up a sandbox or read-only environment where the actions don't affect any actual user data, or implementing the guardrails to prevent agents from accessing sensitive files or performing destructive actions.